Welcome back, learners. So, in the previous session, we have completely understood the major basic options which is available in the ETABS. And now, when we go back to the design of the project that what we have taken, we have obtained the results and we have completely finished the design of the footing as well as its reinforcement. Then we have completely finished the design of the column as well as its reinforcements. So the next step that you are supposed to consider is nothing but the design of beams, right? Okay, now when we come to the design of the beams, you can see here that the beams will be majorly designed for the four stresses. One is the moment, another one is the shear. For the moment as well as for the shear, the beams are majorly designed. Definitely the torsion will also come into the picture, but in this project we are not considering the torsion into the account. We will be designing the member only for the beam. We will be designing the member only for the moment and shear. So when you take up the next project, so in that the torsion will be incorporated, and even how the design variation will be considered, it has to be considered, we will be discussing that in the later. Now, in order to design a particular beam for the moment as well as the shear, you should be knowing what are the values of the moments and the shear in a particular beam. Okay, yeah. So now, when it comes to the beam, you have the concept of simply supported beam, which is only in the theory, where nowhere that will be considered. Practically, it will not be considered at all. Okay, it will not be considered at all in the practice wherever it is not available. The next is the fixed beam. Definitely all my beams has to be the fixed beams, no other options. Okay, all my beams has to be fixed beams, no other options. Or you will be having the continuous beams as well as the cantilever beam. So these are the major three types of beams that you can come across in the day-to-day practical projects, right? So now, in according to that, in order to do any kind of these designs, you majorly need the moment as well as the shear of the each beam. So now let us learn today that how to obtain the moment and shear of the each beam and how to make the category so that it will be easy for us to do the design. So now in order to do that, you just go through the analysis first. Okay, so once the structure is analyzed, okay, okay, so now what we will do is we will take up that there are three sets of beam. One we have here, we call it as the plinth beam. Another one set is the first floor beam. Another one is the roof beam. So now let us concentrate only on the roof beam. Okay, let us concentrate only on the roof beam. Okay, so what I will do is I will just add one more new window. Okay, so in this new window, what I will do, I will unlock the model. Okay, I will unlock the model. Okay. Okay, 1 second, let us see here, view. Yeah. Yeah, now you can see here that this building, it has not been changed. Okay, so I have kept this for the reference. So this building is actually now what it has been done. So it has been completely now, okay, it has been completely now analyzed, and you are getting the deformed shape. Now as I already told that we will go only for the first, we will go for the roof beam. What I will do is I will go to the view. In that view option, I will go to the set the building view limits. I will go to only story 2 because I need only story, therefore I am going only for the story 2, so that it will be easy for me. Okay, so the next one here also, what I will do, I will go to the edit. Okay, I will go to the view, and in the view setting view limits, I am going only for the story 2. Okay, yeah, so this is how I have done. Okay, so now, if you want to see the bending moment and the shear forces of the each and every member, go to the display option. In the display option, you can see that there is an option called force or bar stress diagram. In the force bar stress, you will be having the support or support reaction that we have already seen. We have done it for the design of the footings. So you have the shell stresses or forces, that is when you want to have the design of the slabs. Now when you want to do the design of the beams or columns, you have to go to the frame, pier or spindle or link forces. If you click on that, then it will ask you whether you wanted to show for the case, that is load case, it will be showing the dead and live, or if you wanted comb off. Now since we have done the combination of 1.5 dead load and 1.5 live load, so since that will be the maximum, I will be considering this for the combination of load only. And in that, now I need the moment as well as the shear. Now the maximum moment that I am going to get it is moment 3-3, as well as the shear is going to be 2-2. Okay, so therefore when I select this and when I give apply, okay, so you just click on this, you can see that the moments will be shown for the beams as well as for the columns. Okay, the moments will be shown for the beams as well as for the columns. Similarly, if you wanted shear, you click on shear, and if you apply, then the shear forces will be shown for the beams as well as for the columns. Okay, yes, this is how. So since you want only beams, you can select only beams like this. Okay, yes. Now either you can get it directly from the display option, or else what you can do is I'll just in order to do that, go to the undeformed shape. Okay, or else what I can do is I can go to here also. Here also there is an option that the display frame, pier or spindle. If you click on that, now again the same case, you will get this combination. You want moment as well as shear, right? You can apply, you can get. This is one way. Now if you want to individually see any one particular beam, just click on this and right click on that. Then you can see that the load combination I am using. Now I am getting the major V2. V2 represents the shear along 2-2 direction, and M3, that is moment along 3-3 direction. So this is major shear force and bending moment. So minor shear force and bending moment, and the axial force and torsion, which will not be considered. Right, now when I click on this major shear force and bending moment, you can see the maximum shear force is 24.5, whereas the moment is -38. Whereas if I click on this minor, so you can see that everything is 0, therefore only the major is available. Okay, so after that, if you want for this beam, you can see that this is a larger beam. You can see the major shear force is 54, the bending moment is -168. Okay, so you can see that the minor is 0, right? So even you have an option, you can choose show maximum or scroll for the values. So scroll for the values means you can see here it is -139. That is the moment that you are going to have at the support. Okay, like this you can go, it becomes 0. So negative bending moment. you'll come to the positive bending moment at the center of 114, and again it becomes 0, then it will go to the final 168. You can see here it is 168 at this support and 139 is at this support. Okay, out of this, since you want maximum, you can see the maximum is 168. To be frank, the moment which is going to present at the support will be the negative bending moment, and the moment that is going to observe at the midspan will be the positive bending moment. Okay, yes. So let us see how we are supposed to design. Now in this way, you cannot go and see for each and every individual members, correct? So therefore, now what we have done is, you can see from very clearly from here that this beam is beam number 23, right? So therefore, what I will do, I will go to the display, I will go to the show tables. So in the show tables, you can see that I have to go to the analysis. In the analysis, I wanted to go to the results, and in the results I wanted the frame results, because beam is a frame, so therefore frame results. And in the frame results, our column forces already we have done for the design of columns, so I have to go to the beam forces. I'll click on OK, right? So when I do that, you can see that all the members of each and every beam of each and every story, okay, with its unique name, with all the load combinations, okay, with axial force, with the shear force V2 and V3, then torsion, then you can see moment M2, M3, so everything you will get it. So therefore what I will do, I will just copy this everything, okay, I will just copy this everything. I will go to Excel, okay, I will go to Excel, okay. So then I will just paste it. It will take some time because a very huge number of data is there, okay, so it will take some time to get copied. Yeah, so once it is copied, now what I will do is, I will go here, I will apply the filter. Now I am doing the moments of only the top story, that is story 2. Therefore there itself I will filter that, instead of this I will select only story 2 and I will apply. Okay, and again in that I need only the combination of dead load and live load. Therefore again what I will do, I will go to this, I will select only dead load and live load. So now what happened in the story 2, so these are these different beams that you have, and that corresponding different beams you have the corresponding values, okay, unique name, its load, its station, P, and you know P is not required to me because it is an axial, so you can delete it, okay. Then V2 is required, V3 is not required, you delete it, okay. I think the one more is not, M3 did not came, just give me a minute. Yeah, so yeah, now it will come. Copy. Yeah. So I am copying everything now. We are concentrating only the maximum shear force V22 and the maximum bending moment M33. Okay, so therefore except that, so let us delete all other this one, okay. You can delete unique name also, I don't want, okay. I don't want the station also, P also I don't want, okay. So V3 also I don't want, you know it is 0. The T also I don't want because we are not considering torsion, and this M2 is not required, only V2 and M3. This element, this location, everything you can delete. So after that you just apply the filter, okay. So only I need of story 2 now, and I need only the combination of 1.5 dead load and live load, right. So now again after doing that also, you can see that for this story 2 with beam number 4, these many combinations are there, okay. So therefore what I will do, I will just click on this, Okay, I'll just click on this. So now I'll give the name uh, story 2. Okay, let us see now. Now B4 is there. Now just go to B4, beam number 4, where it is there, you can see beam number 4. Yeah, this is beam number 4 now. Okay, I'll just right click on this. So sorry, I have to go here. So this is beam number 4. That means this is my beam number 4. Okay, you can see that if you see the maximum value, okay, if you see the maximum value, it is 7.3. okay, so you can see that 7.3 here. Okay, then another one is minus 16.48, that is negative bending minus 16.48. okay, so therefore what I can do is I can just make a table, which how I required. Beam number, first one. Okay, then I can directly write V2, no issues, but M3 negative. Okay, then I need one more positive. Okay, so these are the four columns that I needed. Okay, yeah, yes. So now when you click on this, you can see that this is how this is. Shear is 7.3, no issues, but moment whatever you are getting is the negative moment, that is here. Okay, if you scroll down, you will come to know 0. So this is the negative, you are having minus 16, and the positive is 8.4. even that will be there, you can see somewhere here 8.4, you can see the positive one. Okay, so therefore what you are supposed to do, you are supposed to choose in such a way that for this B4, okay, so I am choosing B4. okay, my corresponding shear will be this one. Okay, whereas my negative moment will be this one, whereas my positive moment will be this one. So therefore everything has to be chosen from that. Okay, so like this. So therefore your beam 4 is done. Then go to beam 5. If you choose beam 5, you can see here that out of this the maximum anyhow this is the shear, it will be 20. Okay, so B5 20 will be there, and corresponding the negative will be this one, whereas the maximum will be this one. Okay, so 20 and 36. Okay, so this one sorry, like this 20 and 36. Okay, 20 and 36 and 5.6. okay, so this will be B5, correct. Okay, so this is corresponding to B5. Then next you have is this much of B6. You can see the maximum negative bending moment is these two. Okay, so the maximum negative bending moment is these two, shear and negative bending moment. Okay, whereas the positive bending moment will be 7.194, right. Yeah, so this will be B6. If you want, you can check here B6. You can see that where is B6. Yeah, I think this is B6. Okay, you can see that if you go to scroll down, you can see the maximum negative bending moment out of that will be minus 22 something. what you have written here, minus 22, whereas the positive maximum positive bending moment will be around something 7 point like that. Okay, yes, so like this. Okay, that is B6. So then if you go to B7, again these two, 18 and 52. Okay, 18 and 52, and whereas the maximum positive bending moment will be 4.1. correct? Okay, so this will be B7, right? So this will be B7. Then B8 if you go, okay, B8 if you go, yeah, so this will be the maximum one. No, you have maximum here, B8, 12 and 33. Okay, so 12 and 33, 12 and 33, whereas the positive bending moment that you are going to get maximum is 23. Okay, it is 23, B8. So the next that you can have is B9. Okay, from here to here, the maximum is this one. Okay, and what about positive? Positive, the maximum is 46. Okay, B9. This is all about B9. So the next that you can have is B10, only this much, B10. Out of this, definitely this has to be maximum. Okay, this has to be maximum, and the maximum positive will be 7.6. okay, so that is B10. So next you have B11 here. I think the maximum will be 10 and minus 15, correct? So 10, okay, so 10 minus 15 and positive will be 9.9, right? Okay, that is about B11. Next you have is B14, only this. So I think the maximum will be this one, and what about positive? 1.9. This will be B14, right? Then next you have is B15. Yeah, so these two is maximum, and the positive will be 13. So B15. Next you have is B16, this much. Okay, so B16, the maximum will be these two, and the positive moment will be 6.7. Okay, so the next will be B17. Okay, so B17, this much is there. Out of that, yeah, the maximum will be these two, and the positive moment will be 58. Then next you have B19, yeah, 12.56 maximum, then 31, and the positive will be 15. I think it is B19. Yeah, B19. So the next one you have is B20. So these two, and the positive will be 34. Okay, so that is B20. Next will be B21. Okay, so B21, 3481. Okay, so 3481, and the maximum will be 37. Okay, yeah. So like this, what we will do is we will be doing this for the each beam members, and let us see that how to design it in the next class. Thank you, learners.